Hey Nuggets! So section 5.3, example 3, your turn. I left this one on its own in the video because it's kind of a pain in the butt. This would definitely be considered like a challenger question. So if you find this a little bit much, don't get too panicky. If you can do the basic multiplication and division, then that's, you're meeting the outcome for this chapter. But this, so this would be if you're shooting for 100, these kinds of questions. So we'll go through it together. So we have solve the root of 3 plus j plus the root of 2j minus 1 equals 5, and they give us a restriction, so they tell us that j has to be greater than or equal to 1/2. So this is a restriction. So again, we're going to check our solutions against this restriction. They don't tell us that we have to solve exactly, which means we could get a calculator answer for, or we could use our calculators and get a decimal answer for this if we wanted to. I'm gonna try keep it all in exact form just because we can use that practice, but it's not asked to give it an exact form, so we could give decimal answers when it comes to it. So let's start our process for how we solve this. Okay, we've got the restriction, so that would usually be our first step. That's done. Now our strategy again when we have radicals in an equation, so radical equation, is that we want to get the radical on one side and straight up numbers on the other side. In this case, we're going to see that we have two radical expressions. So I'm just going to pick one and pull it to the other side. So I'm just going to take the first one and I'm going to pull it over to the right-hand side. You could choose either. I just randomly chose that one. It was just the first one. Okay, once we've done this, then we're going to square both sides. Now, when we do that, it's going to give us a nice, neat solution on the left-hand side because we're squaring the square root. That's easy peasy. Stuff is going to get a little bit more complicated on the right-hand side because this is a binomial. So that's where we introduce kind of the extra pain in the butt of this question. So my left-hand side, super easy. The radicand is what's left when I square the square root. For this guy, I'm going to expand that just for my own self. So this is 5 subtract the root of 3 plus j multiplied by 5 subtract the root of 3 plus j. And then using my FOIL method, the skills we just practiced to multiplication. So first term times the first, so 25. First term times the second, so I'm going to have minus 5 times negative 1. So I'm going to change the color of this, hopefully it makes it a little more clear. So 5 times the second term, so 5 times negative root 3 plus j. 5 times negative 1, so negative 5, there we go, root 3 plus j, and then I'm going to get the same thing when I do the second times the first, so minus 5 root 3 plus j, and then last term times the last term, so negative times the negative is going to give me a positive, and it's like I'm squaring a square root, so it's going to pull off the root sign and I'll be left with just the radicand, or 3 plus j. Okay, let's combine on the right-hand side this pile of hot nonsense. So I'm allowed to subtract these two. They are like terms, same index, same radicand, so negative 5 minus 10 root 3 plus j. And then plus 3 plus j. Oh shoot, I could have done some more combining, so it's okay. I'm just going to pull everything to one side anyway. So let's pull everything. Oh, no, I'm not going to do that because I'm still going to want to square this guy. So I'm going to pull everything that's not that to the other side. So 2j minus 1, subtract 25, subtract 3, subtract j equals negative 10 root 3 plus j. Okay, so basically what we're seeing is if we start with two radicals, we're going to have to do this process of squaring both sides twice, and it's going to get a little bit messy, but it is achievable. Okay, combining like terms on the left-hand side, 2j minus j, I'm left with j. All of these are negative, so negative 28, negative 29, so minus 29, and on my right-hand side, minus 10. Root of 3 plus j. Okay, now back up to my same old tricks. So I'm going to square both sides to be able to get rid of that radical sign. So what does this give me when I square it? So again, remember that's the same thing as j subtract 29 times j subtract 29. So I'm going to get j squared minus 29, so minus 58j, and then negative 29 times negative 29 plus 841. Ain't no party like a math party, because a math party don't stop. Oh wow. Okay, negative 10 squared, so I'm going to have 100. And then squaring the square root is going to pull it off, so I'm going to have 100 times 3 plus j. And we continue. So j squared minus 58j plus 841 equals 300 plus 100j. Now I'm going to pull everything to one side, so I'm going to pull everything to the left-hand side just because most of my terms are already over there. So j squared minus 58j minus 100j plus 841, subtract 300 equals 0. So we're still ending up with a quadratic. We just had an extra set of steps because we needed to go through our squaring both sides process twice. So we would have plus 541 equals 0. Now, okay, this is a radical. We can solve this radical any way that we want to. Initially, I had said, yeah, I'm going to keep everything in exact form, but this problem didn't ask us to keep everything in exact form. So I mean, technically we don't have to. We could solve this with our graphing calculator to get the zeros. That's kind of what I feel like doing right now because it's been a long day and working from home sucks, but I'm going to stick it out and I'm going to solve with the quadratic equation so we can get a whole answer. I can't factor that. Somebody better than me maybe could, but this guy definitely can't. So I'm going to use the quadratic equation to get an exact answer for this. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac, and I'm just copying this off of our data sheet, so remember you have it in your data sheet or in the work for chapters 3 and 4 on quadratics. So given my particular equation, my value of a is 1, b is negative 158, and c is 541. Okay, that's what I need to know to be able to solve this quadratic equation. So x is equal to negative minus 158 plus or minus the square root of negative 158 squared. Remember, this is going to be tricky in our calculators. We need to remember brackets around it when we're squaring it so that we're following the order of operations. So 4 times 1 times 541 all over 2 times 1. Well, that part was nice. So x equals 158 plus or minus the square root of, holy moly. Okay, gonna do this all in one step. So 158 squared, I'm just gonna take the negative off myself, so my calculator is, so 158 squared subtract this stuff in brackets. And when I do that all together, I get 22,800. So I don't need, so, oh, well, hello, bam. All of that over 2. Okay. Simplifying this, so equals 158 plus or minus the root of. So to simplify, we are looking at this number and the fact that our index is 2, and we're looking for perfect squares that can divide by this guy. So that process, again, we're not going to list all the perfect squares up to this number. That would be not a helpful process. So you can just start trying stuff if you want to. That's what I did when I was doing this question. So 22,800, I just started with the big ones. So divided by 12 squared, divided by 13 squared, divided by 14 squared. And when you go through that process, you see you can make it a perfect square. You can make it the perfect square of 457. Again, if you need to do this in a series of repeated simplifications, that's cool too. You do you. So equals 158 plus or minus the square root of 400 is 20. And we're left with the root of 57, all divided by 2. Okay, because this coefficient is divisible by 2, and this coefficient is divisible by 2, then I can do both of those to cancel the 2. So I get x is equal to, I'm going to do it below, because I have infinity space, haha. X is equal to 158 divided by 2, 79, plus or minus 20 divided by 2, 10, times the root of 57. Okay, so these are my 2 answers. Remember that we have to check both of them. So to check both of them back in our initial equation, so checking the both of them back in this equation, my suggestion to do that in a way that's not going to drive you totally bonkers is to get a numeric value for each of these. So remember, we've got to do both and we've got to check both. So we have one solution that says x is equal to 79 plus 10 times the square root of 57. And we have a second solution that says x is equal to 79 subtract 10 times the square root of 57. My suggestion to you would be to turn these both into number values. So to turn these both into numbers with our calculator that we're then going to store. So we can store them and then use the stored values to check back in the original equation. So when I change this guy into a number value, I get x equals, oh, and I should use my approximate arrows because it's approximate. So x is approximately 154.498, blah, blah, blah. And here, x is approximately 3.5016. So I would store this guy in A, I would store this guy in B, and then I would use A and B to fill back into my original equation. So I'd be filling this number back into my original equation. So again, I check and say, do they pass the restriction first? If they don't, I can reject them. My restriction was j had to be greater than or equal to 0.5, and both of these pass the restriction. So then when I'm doing the check, I've got the root of 3 plus j plus the root of 2j minus 1 equals 5. And I've got to check both of these, but I'm going to use the stored values to fill in for j. I like practice, but we don't need that much practice. At some point it just starts to be monotonous. So as I'm checking, I'd fill in and say here, so I'm filling in A, I'm filling in A, and over here I'm filling in B, I'm filling in B. And I'm going to see, does my left side equal my right side? So when I do that on this guy, I get 30.099, approximately that, equals 5, so no dice. My left side does not equal my right side, so I'm going to reject this root. So I'm going to say that this root is extraneous. So this is an extraneous root. Do not accept. When I do this on my right hand side, so for this root, and I'm saying x, but j is equal to, when I do this for this side, I get 5 is equal to 5, left side equals the right side, we are good. So the only solution to this question is x, or j is the variable we're using. J is equal to 79, subtract 10, root of 57, or j is equal to approximately 3.5. Okay, I hope that helps. This is the last video for section 5.3. So it's the last video I'll make for chapter 5. I'm not going to get you to go through example for your turn. So you have what you need to be able to do all of the practice questions. And just remember that this last one, this would really be like a skill testing question. So this would be to differentiate between the standard of achievement and the standard of excellence. So this would definitely be a standard of excellence question. So don't be too stressed if this last one you find a little bit much, especially since we're not together. So if you can do example 1 and 2 your turn, then you should be well situated to do most of the practice problems, and you will understand these outcomes to an acceptable standard. So there you go. Thanks guys again for being really patient. I really appreciate it, and I can't wait until we are back together again. Bye.